I've not taken the mic, so sorry for a 1 minute break. So grading in a class, good comments and group work is also awarded. I try to measure everything. So basics, this is the basics of a graph. A simple example of the graph where you can see the sales data over here and the advertisement experiment over here. So yellow line you can see over there. Yellow line will say showing the sales data over here and the advertisement expenditure. How you can see the sales data has been increases when the advertisement expenditure has been increases, the sales data has been increases over here. So you can see that the advertisement expenses has been increases. The same time the sales data has been increases over here. So this is shown over here. The advertisement expenditure is directly proportional to the sales. How much advertisement you are doing, the number of sales data, so number of sales or number of product sales has been increases. So it is advertisement expenditure is directly proportional to your sales. Here it is shown. So basic problem: endogeneity, circularity, egg and chicken, and causality and correction. Two very different concepts. So these are basic problems which is related with this. So basic problem number one: interpretation of any graph oblique table implies many assumptions. When you see this graph first time, so you are doing the assumption. So assumption comes in your mind that sales and base increases. We can find that when we are expanding more and more in the advertisement, the sales has been increased. There is a first assumption in your mind come. So you can see that. So when the interpretation of any graph or table, when you're going to interpret or read any graph or table, it is imply many assumption in your mind. However, these assumptions are almost never explicit. Assumptions for interpretation of the previous graph, which is direct or omission. You can see over here the previous graph over here, so it is direct or omission. So this is the assumption. So whenever we can see the graph, we are doing the assumption for the another period. Just like in each and every time when the sales and bid increases, when we suppose we have two things. When we have here we have a number of people and there we have sales. So we have found that when the number of people have increased in the sales has been increases. So we found that. So in the next period, if we are going to add more number of people, so our sales will be increased like that. So basics 2. In 1936, US presidential election sampling list mail out ballot card to resident telephone subscribe and owners of the car. Result of the poll: London Republic will win with this 57% of the vote over Roosevelt Democrat. So what they have done, they have advertised. Here we can see in the example they have advertised. I mean to say London Republican Party has been advertised over Roosevelt Democrat, over Democratic Party. So Republican Party has been advertised there more and more. I mean to say, so it will reach out in the mind of the more and more Americans or yes people that. Regarding the Republican Party, so they have won at that time. So the number of time is impacting in your mind when you're suppose when you want to dial some number, when you pick up the call, when you got some ring and you want to pick up the call. Suppose it is initial 5 or 10 seconds, you got some advertisement regarding the Republican Party that if you're going to give a vote to Republican Party, you will get this, you will get that. So it will impact directly to your mind each and every time. Suppose in the day, 10 times you're receiving a call or you're dialing a number, the same thing 10 times come to your mind. So obviously it is repeating. So it will anyhow impacting in your mind, and so each and every time. So what happened each and every time it is impacting on your mind. So it is anyhow it will give the boost to the Republican Party to win over Roosevelt Democratic Party. So basics 2, outcomes of the election. Roosevelt won from 62.5% of the vote, electrical vote. So what happened? Group exercise. This is nothing but a group exercise. Basic problem 2, sample election problem. Training course of an employee. This is the group work. Training course of an employee is a group work. Training course of employees is a group work. So basic problem number 2, therapy of hormonal replacement of a woman of menopause. Does it work? Possible problem. Situation, how did the result of observation data go wrong? It's a group exercise. Solution, if possible, randomized experiment. Example, the business, this alternative is never available. Look for another design, clever regression. So these are the things. So suppose you want to take some data. So you are doing this survey. With the help of the survey, you will get number of data. On those number of data, you are doing your own analysis. Just like in the census. In the census, what government of India has do? Government in India in the census, it will go each and every home. They will collect the data from each and every home, and after that they will analyze on that in India we have around this number of people. Suppose 100 crore people. We have a 100 crore people in India, and in which this much 50 to 60% literacy over there, and in the urban area literacy is high, in the rural area literacy is low, and the ages we have in India, we have around 60% of people who is below 40. So we have a young crowd more and more in India. Like that, this kind of assumption has come while they are doing the census. In the census, we know each and everything. How many people are there in the home, how their ages, their education, their service. So each and everything we got to know. On the basis of that, the government of India do the assumption. They are doing the assumption, and on that, and they are keeping the record. So important. Statistical methods are never wrong. They are never wrong. First, keep in your mind. It is their application by clumsy, unexperienced, or careless researchers that made the result wrong. It is their application by clumsy, unexperienced, or careless researchers that makes them result wrong. See, sometimes the result will be wrong because of the clumsy and unexperienced people who they are doing the research, and they are carelessly research make the data, make the statistical method will be wrong. Remember, if you get the design, assumption, or data right, the result will always be right. If you get the correct data, why the result will not come right? So when you're getting a proper data, when you're going to correct data, the result will be right. Suppose in the census, I will give you the example. In the census, what happened? Government gave the authority to the people who's working under government, that you have to go each and every house and you have to collect the data in the format like the age, the number of the people in the family, age of the people, those who belongs to family, their education, their service, their work, what they are doing, how many ladies are there, how many gents are there, and after in the last expectation from the government, like that, suppose. So what the government servant will do, government has give the restrictions. You have to go at least 100 houses in a day, and you have to collect these data. But what the government people has do, public servant, they will not go at the 100 house. They will go for around 10 to 20 house, and they will collect the data. And apart after the 20 house, they will make their own the next 80 data. They will make their own. So what happened here? Government will not get the proper result. They will get the result, 20% is accurate result and 80% is a fake result. What the government public servant has done. So here what happened? So government will not did not get the accurate data. So there is a problem. So the researcher is not able to give you the proper result. Over here what happened? The same thing have written over here. So it is application by clumsy, unexperienced and careless researchers that makes the result wrong. Most of the time statistical methods are never wrong. Objectives: logical thinking using statistical facts. We are using the logical thinking. We are applying the logical thoughts to get the proper results. Proper interpretation of statistical data. So whatever the data you get, I mean to say, when you are seeing the graph, you have to do the interpretation of the statistical results. Posing hypothesis and checking their likelihood. You are posing their hypothesis and checking the likelihood. Sources of data. What the sources of data you will find over here. From which source you get the data, each and everything you will find over here. Posing hypothesis and checking their likelihood. So you will get the sources of the data over here. Two types of statistics. Here we have talked about the statistics. There is a two types of statistics. Number one, descriptive. Descriptive statistics of a population. So descriptive statistics of the population, just like relevant notation in the Greek, just like this, sum. This is the sign of sum. This is the sign of mean. So this is the sign of mu, which is nothing but mean, and which is population size and their sum. So mean, their population size and sum. And inferential statistics of samples from the population. So we are taking the samples from the population, and what we are doing, assumptions are made that the sample reflects the population in the unbiased form. Roman notation like x is equal to mean, sample size and sum. So mean, sample size or sum. So this is the descriptive statistics of a population, and it is inferential statistics of a sample from a population. So here we'll get mean, here we'll get mean, the sample size, the population size, sample sum is same. So assumptions are made that the sample reflect the population in an unbiased form, Roman notation like this. Be careful though, because you may want to use inferential statistics even when you are dealing with whole population. You are dealing with the whole entire population. In the big population you are doing the data. So measurement error or missing data may mean that if you are treating a population as complete, that we may have insufficient estimate. It depends on type of data and project. Example, democratic peace. So it depends on the data of how the data has been represented, how the project has been represented. It depends on that. So measurement error or missing data may mean that it be treating a population as complete. That maybe have a insufficient. So if there is insufficient estimation, insufficient data, so there is an issue. Also be careful about the phrase descriptive statistics. It is used generally in the place of measure of central tendency and dispersion of inferential statistics. So another name of is summary statistics, which may univariate, just like mean, median, mode, range, standard, deviation, variance, min, max, etc. So measure of central tendency. These measurements tap into average distribution of set of scores or values in the data. So we have three things: mean, median and mode. So they will give you some data, chunk of data. With the help of that, we have to calculate mean of those data, median of those data and mode of those data. So what do you mean mean? First we are going to learn mean. We will do the mathematically mean also, but here we have to going to learn the mean. How we'll solve the mean, how we'll get the mean. So we're going to learn mean over here. So mean. The mean of some data is average, score or value. This is the average. such as the average of an MPA student or average weight of a professor that like to eat donuts. The inferential mean of a sample X is equal to summation of X by N. The mean of a population mu is equal to summation of X by N. Problem of being mean. The main problem associated with the mean value of some data is that it's a sensitive or outliers. Example, the average weight of a political science professor might be affected if there was one in the department that weighed 600 pounds. So this is the average. Let's see how we calculate. So let's start with calculating this mean. So we are going to calculate mean with the help of one. What we will do? We will search Notepad. We will open the Notepad, and now what I will do, suppose there is students, and there is students, they got marks in first in maths and economics. There is two subjects, maths and economics. So they got marks, maths like 21, economics out of 50, 32, 42, 30, they got again 21, here got 29, then again 28, 35, then we have a 41, here again 35. How many are there? 3 to 5, take 10 at least. We have here again, suppose 51, here 11, then here got 25, here got 32, here got 21 again, here got 15, here got 26, here we have got 43. How many students are there? 1 2 3 4 5 6 7 8 9, one more, 30, 46. Okay, so this is the students and these are the marks. 1 2 3 4 5 6 7 8 9 10. These are the marks in mathematics and economics. So what the principal want, what the principal or dean of the college or dean of the university want, they want the mean. Mean means average. They want mean for maths and economics marks. They want the mean. They want what the principal want. They want the mean for maths and economics marks. So what the person will do, they will, for mean, the formula is like mean equal to summation of marks divided by number of students. So what we'll do, so mean of maths what will do, so I will add this. So calculator, we will see, we will search calculator. So what I will do, 21 plus 42 plus 21 plus 28 plus 41 plus 50 plus 25 plus 21 plus 26 plus 30. 305. There is a marks has been 305 has come. Total marks is 305, which is divided by number of students is 10. So value of mean is equal to 30.5. So this is the average marks. Mean is nothing but the average. So this is the average marks has been obtained in maths. Same thing we can do in the mean of economics. We can see that 32 plus 30 plus 29 plus 35 plus 11 plus 32 plus 15 plus 43 plus 46, 272. So 272 again divided by 10, which is nothing but 27.2. So this is the average mark has been obtained in the economics. So you can see that. So what is the marks obtained in the class for maths and what is the marks has been obtained in the economics we have calculated over here. Now go to the problem. So we can see that the problem of being mean. So the main problem. So the main problem associated with the mean value of some data is that it is sensitivity to outliers. An example, the average weight of the political science professor might be affected if there was one of the department that weighted 600 pounds. Let's see. See, there is a professor. They have a weight. So do not eating professor. They have a weight just like Smugglers, Bobsy, Petito. These are the professor's name, and they have their weight over here like this, and they have weight over like this. So you can see that the professor have 1, 2, 3, 4. Their weight is here, and what they have done 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 professor is there. When we are going to add this professor and divide it by 12, you will get 194.6. So this is the mean of the professor. The same thing you can find over here. Only the two professors, see 189, it is changed with 410, and 187, it is changed with 610. Apart from these two, every professor is there, same way. So when you're going to add this divided by 12, you will get 248.3. So here you have seen that when the age has been changed, the value of mean has been changed. So this is I have shown over here in the example. So this is the mean, how he has calculated the mean over here, the same way I have shown over here. So the same way I have shown you over here. This is the mean, how we calculate the mean. This is shown over here, exactly the same way they have calculated the mean over here. Let's see how they have calculated. I can show you. 1 second, I will check with search. I will take the calculator. I will show you. So I will take 165 plus 213 plus 189 plus 187 plus 165 plus 148 plus 251 plus 308 plus 151 plus 132 plus 199 plus 227 equal to 2335. When the 2235 is divided by 12, you will get 194.58. You will get 194.58, which is nothing but 194.6, which is shown over here. So this is the mean. How we calculate the mean? You can see over here. This is the simplest way to calculate the mean of anything. So again, median. So not the cement in the middle of the road. So median, what exactly the mean? Because the mean average can be sensitive in extreme values, the mean is sometimes useful and more accurate. This median is more accurate than the mean. So median is simply the middle value among some scores of a variable. No standard formula for its computation. So it is nothing but a middle value. So we are calculating the middle value in the median. So how they have calculated? Let's see. So they have 165, 1213. So what they have done, they have added this entire value and divided by same 12. This is the way. But what they have to do, they have added this value. It has been come. Two three three five. When you're going to 2335, so the same thing. What they have done, it is divided by the 12. You will get the same value, 194.6. This is the same value which they have used for mean also, median. They have used for median also. Basically, the median will calculate it like when they want to calculate the median for these numbers. So you have to check the middle value. So for the middle value, median, how will calculate the median for economics? So median for economics basically come median for economics. Median for first we'll take math. Median for math will come. There is a 10 value, so we have to take the middle value. Median is nothing but a middle. So 10 plus 1 divided by 2. So it will come you, which is nothing but 11 by 2. 11 divided by 2, which is 5.5. So here is two values. So you have to take 5 and 6 values. So 1, 2, 3, 4, 5, 41 and 50. So you have to take 41 plus 50, 5 and 6 and divided by 2. So you will get around 41 plus 50, 91 by divided by 2. 91 divided by 2 is nothing but, 91 is divided by 2, you will get around 45 point something. So this is the median value which is closer to you. You will take that. So 45 and 50, these are the two median value over here. These are the two median value. Basically, in the median value, what we have to do, we have to calculate if the there is if the number of values, there is a rule for median. If the number of values is positive, means even, then you have to directly what you have to do, n by 2. So directly you have to calculate like this. So 10 by 2 here, 10 by 2, which is nothing but a 5. So this is 5 number of 1, 2, 3, 4, 5. So 41, 1, 2, 3, 4, 5. Yes. So 41 become your median over here. If the number of value is odd, so you have to do n plus 1 by 2. So if the value is odd, then n plus 1 by 2 over here. So but here it is, I don't know how they have taken something different methods they have applied over here. So next, percentile. If we know the median, then we can go up or down and rank the data as being above or below certain thresholds. You can be familiar with the standardized test 90 percentile. Your score was higher than the 90% of the rest of the sample. Then the mode, hold the pi and ALA. What does ALA takes like anyway? The most frequent response or value, which is called the mode or a variable. Multiple modes are possible in bimodal and multimodal. So you can see that how we calculate the modes over here in our example. So for mode, what we can do, so mode for maths, you can see number of the value which is repeating. So 21 is 1, 2, 3 times. So for math, mode is 21. Then mode for economics. So we have seen that what is the repeating value over here? 32 1, 35 2 times. So 32 and 35. So 32 and 35 is a mode for this. 32 and comma 35. These are the modes for these. So repeating value which is repeating, that is a mode. This is the mode for the most frequent response or value for a variable which is most frequently come. So multiple modes are possible. Bimodal, which is I have seen this is bimodal, and or multimodal be that is also possible. The figuring of a mode. What is the mode for this? You can see that which number is repeating over here. 165. 165 is here. Then again 165 is here. So 165 should be mode. So answer is 165. So 165 we can see that 165 is here, and apart from this here is also 165. Then we cannot find the 165. The answer is 165, which is repeating more and more. So important descriptive information that may help inform you research and diagnose problem like lack of variability. Important descriptive information. So now slides, we are reached to 26. Okay. Measures of dispersion, not something you cast. So measure of dispersion tell us about variety of data, variability in a data, also univariant. So dispersion is asked about the variety of data, how the variability of the data will got. Basic equation, how much do values differ for a variable from min to max, and distance among scores in between we use. So range, standard deviation and variance, these have seen over here. So basic question, these are the basic questions. How much do values differ for a variable? How much value will differ for a variable? We can see over here how much value differ from a variable from minimum to maximum, how much value is varying, and distance among scores, and how much distance, how much from when the value is varying, so how much distance, in the sense just like value is varying from 25 to 50, so distance is 25, because initially it was 25, now it become 50, so distance is from 25 to 50 is 25. We use range, standard deviation and variance. Remember that we said in order to glean, we said in order to glean information from data, that is to make an inference, we need to see variability in our variables. We have to see the variability in our variables. Measure of dispersion give us information about how much our variables vary from the mean, because if they don't, it make it difficult infer anything from the data. Dispersion is also known as the spread of the range of the variability. So dispersion basically it's a range of variability, how the range has been spread over there. So this is about the dispersion. Measure of dispersion give us information about how much our variable vary from the mean, because if we don't, it makes it difficult infer anything from the data. Dispersion is also known as spread or range of the variability. So the range, how will it take the range? R is equal to H minus L, where H is high and R is low. So this is the range. From high minus low, just like if I have told you that we want to consider a range, one person gets the 50 marks, another person gets the 50 marks in one subject. So range between 50 minus 25, which is nothing but 25. So in other words, the range gives us the value between minimum and maximum values of a variable, which I have told you, maximum minus minimum. So we have to present the range is equal to maximum minus minimum, which is high minus low. To understand the static is important in understanding your data, especially for management and diagnostic purposes. Understanding this statistics is important in understanding your data, especially for management and diagnostic purpose over here. Basically, we are doing the statistics for this is basically a diagnostic purpose. We are diagnostic something. Diagnostic purpose in the we are diagnostic something. We are analyze something. Diagnostic in the sense analyzing. We are basically analyzing something. While we are analyzing the things, then only we will get the accurate data. My mind is in the initial slide I have told you the statistics is always be a right. So until and unless you are getting the wrong data, if you are getting the wrong data, you will get the wrong result. If you are getting the perfect data, statistics will show you the perfect result. What we have seen in the last slide, in the basic problem, where we have learned about statistical methods are never wrong. Either and unless you will get the wrong data, you will get the wrong. So it is their application by clumsy, inexperienced or careless researchers that makes the results wrong. Otherwise, you will get the right result. So each and every time, in what way you are going to do, you will get the right result in the statistics. So understanding the statistics is very important in understanding your data, especially for management and diagnostic purposes. So standard deviation. Standard deviation, I have told you in time series and analysis, it's shown by lambda. So a standardized measure of distance from the mean. The standardized deviation the standardized measure of distance from mean, very useful and something you do read about what making prediction or other statement about the data. So this is very important. When you're getting some data, it is very useful. Something you do read about the making prediction. So basically here we are also doing the prediction of the data. While you are doing the prediction of the data, so at the time of prediction, I have told you the forecasting or prediction you are doing over here. So while you are doing the prediction of forecasting, with the help of the graph, so you got to know about how much we can do and where we are behind, how much lacking, or how we can achieve more and more. So this is the formula for the standard deviation, where standard deviation S is equal to x minus x bar square upon n minus 1. So this is square of root sigma. S is sum, sigma which is called sum. This is called sigma. Score for each point in a data. X is score for each point. X bar is equal to means of a score of the. So x bar is showing a mean. This is showing a mean. So we have to calculate here score and here is score. My mind is a mean. This n is sample size minus 1, number of observation of the cases, n minus 1. So when you're going to calculate this, you are going to get the standard deviation. So see, this is the same what we have seen in the previous class. So this is x, this is the x, this is mean of this x, and this x mean is squared. So square of this is nothing but a square of 29.6. 165. So this is the mean over here, and there is square x mean. So we can see that the standard deviation equal to the 165.2 pounds. The weight of the jinger is still likely skewing this calculation. So you have seen that you have x, this is the value of x, you want to go for x bar, this is the mean of x bar. So x minus x bar square, so x minus x bar square upon n minus 1. Score of each point of data and score of mean of score for standard variable. So after that you will get the mean over here like that. This is a simple example. You have to only put the data in each and everywhere in this format, in this formula. So example of S in use. X is standard deviation. Boehmer-Sobek paper. This is example. One standard deviation increase in the value of X variable, increase the probability of Y occurring of some amount. So one value is increased, so another value is increased. Like that, this is shown over here. So development of a relative risk of territorial claim. So you can see the baseline. This is the development. Percentage change over here. Pop density, pop growth, capability, openness, capability of pop growth over here. So percentage change in probe after 1 SG change in given X variable, holding other at their means. So this is other their means. It is shown over here. Let's go to computer. Type of data in the, forget that. Then variance, this is the same. S square. When you go into S square, so there is no need to give you the square root over here. When there is a S square, so there is no need to give the square root over here. Note that this is the same equation except for the no square root has been taken. What I have told you, it is used not often directly reported in the research, but instead of building block for another statistical method. So organizing and graphing of data. Now we can see that the organizing and graphing of the data. This is the different way we can plotting our graph. So this is the way it is going up and down. This is somehow we going to give the sales data. This is chart, pie chart kind of thing. This is some another graph, and this is some another way of showing a graph over here. So this is the way you can also show the population of a country, where you can see that you can show like that. The blue part is showing the young people in the India, and this part showing the literacy, this part showing the another thing like that. You can show the graph. What is the goal of graph? Why we want the graph? So it is the presentation of descriptive graphics, statistics, descriptive statistics. Basically, when you plotting a graph through the statistics, it is a descriptive statistics which is called. Representation of evidence. We are giving you the presentation of evidence. Some people understand subject matter better than the visual sides. So there is no visual sides. If you are going to give them graphs, they will understand more and more. So provide a sense of understanding data generating process. So this is the important. Provide a sense of understanding. So they will understand the things very fast. Rather, if you are going to give them text, give them graph solutions, so they will understand these things very easily, and they, according to that, they can choose their they can take their decision what they want. So what is this is kind of distribution graph. So gives a picture of a variability and center tendency. Can also show the amount of skewness and kurtosis. This is kind of graph. This is the which is called the variability graph. The graphic data types. This is the graphic data types. So you can see log development and probability of mid over territory. So it is shown over here. So the effect of development of the state involvement in the MID over territory. So this is another kind of graph. So creating frequencies. We create frequencies by sorting data by value or creating category and then summing the cases that fall into those values. How often do certain scores occur? This is the basic descriptive data question. So these things we can see in the graph. So we have seen the same eating donut problem, most of the list. So 3, 5, 7, 9, 3, 12, the same thing. So we can see that here we have placed the professor into weight class and depict the histogram in columns. So you can see that so this is the number of professor over here, and this is the number, and here we have seen the weight. So we can see that 308, in the 308 only, between 270 and 310, how many professors are there? 271 to 310. So we can see that in this graph, between 271 and 310, only one professor is here. So this is 308 weight. So we can see that 308 only one professor here. And after 311, there is only one professor. So it is shown over here like that. This is the plotting, the way we have plotted the graph. Then here is another histogram of the same donut matching. Here, this is the another way. Proportion of donut professor by weight class. So this is another way to plot the graph. Proportion of donating professor by weight class. Some Excel for other options. This is some other Excel option. And this is the bar graph or time series. Basically, this is used in a time series. Time series approval and economic approval and approval. Then presidential approval of unemployment. This is the some other scattered plot. So this we have seen. So all these graphs, what we have seen over here from first to last, whatever the graph we have seen from this graph, either we have seen this graph or this graph or this graph. So this is the way of representing any of the value over here. You can directly plot the graph and you will get these graphs directly from the either you can go ahead either you will get from here, and either second thing you will also get in the Excel sheet. You can directly put the data into your Excel and you will get directly this kind of graph. So we have learned how in the statistical problem how to create a graph, how to plot a graph. Again I will come again and I will show once again how we'll calculate the mean median mode over here. So we have because this is a little bit difficult because we have learned, not difficult because we have learned this thing a long back, so might be not occur in the mind. So how we'll do this? So we have a two problem over here. We have a group of students for maths and economics, and what we need to do, we need to calculate. We have marks over here for 10 students for economics and maths. Now what we need to do, we need to find out the mean, median and mode for these students for maths and as well as for economics. So first we have to find out the mean for maths. So here we have seen there is a 10 students and the marks. So what we need to do, we need to add those marks and divide it by how many numbers are the students, or how many students we have taken. So summation of number, which is I'm going to add all these marks, which is nothing but a 305, and divided by the number of students, a number of subjects, I can say that number of students over here because we have taken the students. So 305 by 10 is 3.5. So mean or average for the math subject is 30.5, subject math 30.5. The same we have done with the economics. So mean for the economics it becomes 27.2 because its total is 272, and which while we are dividing by 10 it's come 27.2. The again median for maths. Median for maths, I can say that, see, there is n by 2. N by 2, see, there is two ways to find out the median. Median find out, to find out the median, we have to choose, we have to see that the n number of students, how many, either it is coming even or odd. If they are coming even, then we can directly put n by 2, which is nothing but 10 by 2, which is 5. So we have to check 5 is coming 1, 2, 3, 4, 5. So 41 is become median for maths. The same thing for economics. So 1, 2, 3, 4, 5. 35 is become median for the economics. So if it is number become n by 2, it become odd, suppose 11 or 13. So that time we have to calculate n by 2 comma n plus 1 by 2. So there is a two median will come. So if suppose become 11, so 5 and 6 both value will come. And for mode, what we need to do in a mode, we need to choose that value which is repeating. So in the math I have seen that 21 is repeating 3 times, so 21 become a mode. In the economics we have seen that 32 is repeating 2 times and 35 is also repeating 2 times. So mode for the economics become 32 and 35. So we have completed here mean, median, mode, and some statistics, what we can say that for the managers. And we have seen that the different way of plotting the graph. Again we can see that. So this is the way we have seen that the donut eating professor over here, and this is the way of plotting the graph over here. They are plotting the graph for these donuts eating professors. So how the different way we can plot the graph. So this is the simplest way to plotting the graph, where we are getting the sales data. And another here, the number, with the help of number, this is another way to plotting the graph. This is another way of plotting the graph where we in the circle we have bifurcated each and everything. This is another way. It is somehow same, but this is another option, and this is something different. Line graph, for basically it is used for time series, and a scattered plot basically something is different. So we have learned today almost about initial. I have started with the quantitative approach, where we have learned about the decision theory, how we'll take the decision, how the management has involved in the decision. So for each and every decision, management has been involved, either related with the sales, profit, and then after that we have seen the maximization of the profit with the help of LPP, linear programming, how we'll calculate the maximizing the profit. And here we have in the static side we have seen the bar graph, how we'll creating how will mean, median, mode, how we'll calculate the mean, median, mode of any number of. We have seen the population graph. We have seen here how we'll make the graph with the help of the given data. We have seen the standard deviation, how we calculate the standard deviation over here. If you want, you can see the standard deviation over here. See, this is the standard deviation simple formula. So here these things you have to keep in your mind, how we'll calculate the standard deviation, which is summation x minus x bar, which is x bar is your mean of that particular number, and n minus 1. This is the simple. And after that we have calculated over here the standard deviation. Then we have used the standard deviation over with the help of a square. S square, when you're going to remove that square root, the S square will come. So this is the all denotion of the standard